Hello everybody, and welcome to today's Dynamics 365 Tech Talk. Today's topic is Unified Dev ALM for Finance and Operations. My name is Takami Sendo, and I'll be your moderator today. Presenting for us today from Microsoft, we have Pankaj Thakur, Principal Software Engineer, Sourabh Namilikonda, Software Engineer 2, Ankur Srivastava, Senior Solution Architect, and Priyanka Sinha, Senior Solution Architect. This Tech Talk is the third one of this series. Session 1 and 2 are already available on YouTube. If you haven't already, we recommend to watch those two sessions as well. So let's get started. Priyanka, over to you.
Thanks, Taka. Hello, everyone. So in this session, we will introduce you to the Unified Dev ALM, starting with the first step of ALM, which involves beginning with Azure DevOps configuration. Throughout our discussions, we will be using Git as our version control system for all the topics and demonstrations. Please note, we won't be covering the basics of Git, but you can find more information in the resource section if needed. Next, we will discuss version control and branching strategy at a high level. After briefing on Azure DevOps, version control, and branching, we will proceed to development release, including continuous integration and deployment, featuring several insightful demonstrations. So moving to objective. So first questions comes that what could you do with Unified Dev ALM, and what are those recommendations when you are going to follow the ALM? We recommend using Git for version control since it has become the preferred version control system in Azure repos. While some still rely on TFVC, and we don't intend to remove this feature set. Unified Dev ALM also enables working with artifacts and supports the entire cycle from build to release. We have tasks for various actions within a pipeline, such as building solutions, compiling, executing unit tests, creating deployable package, and more. This also facilitates building and deploying solutions through a continuous integration and deployment pipeline. Moreover, Unified ALM allows for the implementation of consistent development policies across applications and teams. Other standard features can also be utilized, such as auditing, code review, and code release approvals, change management, signing, and there are many more. So let's go through the unified application lifecycle. When we initiate an implementation project, the design and development phase will involve developments either in FNO or in Dataverse, or in both FNO and Dataverse. And the source code will be stored in source control, as we always do. And through the use of a build agent and build pipeline, we will obtain a unified package. To deploy this unified package to target environments, we need to have PackCLI. We will be providing more details and demonstrations in upcoming slides about PackCLI, how to install and how to use. Before we start any implementation, we must need to set up the Azure DevOps. When we start configuring the Azure DevOps, these are some major steps to get started. First, you need to sign up for Azure DevOps, create your account, and initiate a new project. When configuring your Azure DevOps, we recommend to use Git, as we already mentioned that it is widely recognized version control system in software industry. However, if you want to continue using TFVC, we don't intend to remove this feature. So you may continue using TFVC as well. You also need to consider the setup, which is called disable creation of TFVC repositories, which is in organization setting repos repositories. And enabling this checkbox will prevent the creation of new TFVC repository, but this will not affect any existing ones. And then proceed to create an Azure DevOps team project. And then within your team project, you have to establish your folder structure for your repositories. Finally, initialize your repository to start version control and collaborate on your project. Here, these are some specific steps for finance and operation you have to configure. So you will have to install Dynamics 365 Finance and Operation tools from Visual Studio Micro Marketplace. And it has to be done in your DevOps project. This extension provides Azure DevOps build and release tasks. And then you have to connect your Visual Studio with your team's project and then map or clone your Azure DevOps project to your local model store and project folder. With this, you will have your Visual Studio setup and connected with Azure DevOps project. And here we have listed the steps which are required for customer engagement. Please go through those links which we have provided at the down. You will find more details, but these are the separate steps has to be followed for customer engagement. We have now covered the key components of setting up Azure DevOps. The next step in Dev ALM involves defining the version control and branching strategy. I would hand over to Ankur to talk about those aspects. Over to you, Ankur.
Thanks, Priyanka. So let's discuss the version control practices we use for D365 projects. Effective version control is the backbone of any successful software development process, which ensures that all our code base remains organized, consistent, and traceable. So now let's talk about version control using Git. So Git operates as a distributed version control system, allowing each developer to have a complete copy of the repository on their local machine. This setup ensures that they can work independently and maintain full functionality without relying on a network connection. So with Git, developers can commit changes locally and carry out version control operations such as viewing history and comparing versions, all without the need for a network connection. This capability significantly enhances productivity and flexibility in the development. Git support, the lightweight branching, and it allows developers to swiftly create and manage branches locally. This is particularly useful for developing different features or variations of the code base. Developers can effortlessly switch between branches to work on various features or code base variations. This feature enables developers to transition smoothly between different tasks, thereby improving workflow efficiency and allowing for effective multitasking. When changes are ready to be integrated, branches can be merged easily. Developers can also have the options to publish branches for team collaboration or dispose of them when they are no longer needed. In the last, Git integrates seamlessly with Visual Studio and Azure DevOps, and it is also compatible with third-party Git services and clients. This integration provides developers with flexibility in their tool usage and development workflow. Now, let's talk about this slide. Basically, we all know that Git is the modern industry standard for version control. It's also Microsoft default version control system provider that we recommend for general development. As we all know that for X++ developers, they are already familiar with the existing guidance to set up team foundation version control for X++. But many organizations are standardizing on Git. Given the increasing developer preferences for Git, it is valuable to discuss how workflow can be mapped between TFVC and Git to facilitate a smooth transition. So here is this table compares various operations in team foundation version control and the Git workflows. It outlines the corresponding commands and procedures for common version control tasks, like creating workspaces, committing code, branching, resolving conflict, code review. To maintain high standard in our development process, we must establish several source control guidelines. So starting from these includes preventing direct commits to the main branch and ensuring all changes are reviewed before integration, which facilitates thorough code review process and ensures quality and consistency. By linking pull requests to tasks or issues, we enhance the traceability part. Now, we also emphasize the importance of informative commit messages to maintain a clear project history. To protect sensitive data, we ensure secrets are not included in commits and implement credential scanning. Additionally, we adhere to open source software OSS standards by including the required files in the default branch. Let's talk about branching. So to ensure the stability and efficiency of finance and operations development environment, it is crucial to implement a robust branching strategy. And we all know that what are the factors which influence branching configuration. Basically, there are different dev teams, they have the different preferences. The same way, what current phase of your Dynamics 365 implementation is going, and based on that, team decide to have the branching configuration. So, but in any circumstances, what we recommend that team should consider the minimum branching criteria. And what it is like, basically, the first point which says isolation of untested development code, which says basically, developers should be protected where teammates, can accidentally break any active development branch. The second point is basically isolation of in-development code from test-eligible code. And what it means actually, the code changes might pass unit testing or manual developer testing. The associated task might not yet be ready for functional testing. So any X++ branching structure should clearly notate when a collection of changes is ready for functional testing. Third point is basically the fundamental purpose of all version control is to help prevent code releases to production environments until code changes have been fully validated. So it is very important point where we should not push any changes to production environment until we are sure that it does not cause any issue. The last point is that all the customizations should go with full validation process. So to ensure robust code management, our branching strategy should include scenarios like isolation of developer features to prevent premature production deployment, stabilization branches for UAT and SIT scenarios, and hotfix branches for creating and releasing hotfix packages to production. Now, let's talk about, branching in Git basically, but let's explore the branching strategy we employ for D365 project, because we always talk about Git. So in all the projects, we can use Git. So adopting an effective branching strategy is essential for ensuring a structured and productive development process. So here are a few key guidelines which we follow, and we also recommend the same thing. So these are the standard guidelines and not very specific to FNO. So when developing new features or fixing bugs, always create a feature branch based off the main branch. This approach ensures that even small fixes and changes are isolated in their own feature branches, promoting better organization and traceability. So you can see in this particular picture where we are talking about main branch and then a separate feature branch or separate for bug fix, a branch. All code changes should be merged through pull request. So this process ensures that every changes undergoes a thorough review, maintaining the quality and integrity of our code base. It is crucial that the main branch remains in a high quality state. The code should always pass test, build cleanly, and be up to date. Implementing a branch policy for the main branch helps in enforcing these standards. For managing release, create a release branch from the main branch. When fixing bugs, create branches from the release branch and merge them back into it via pull request. So this method helps in keeping the release process organized and controlled. So now next, we will talk about development and release process. I will hand over it to Pankaj. Pankaj, over to you.
Thank you so much, Ankur and Priyanka. So as you see, the basic flow involves first having a repo in the cloud, preferably in Azure DevOps. And then because Git is so distributed, you need to enlist that repo to your developer machine. You want to work in feature branches, many different feature branches if you are working simultaneously on different aspects of your FNO project. Whatever you work on locally, you can do, commits to keep things organized. But when you are ready for others to kind of look at your code, you push the code to the cloud, Azure DevOps main branch. And you do that by raising a pull request. So we cover that. And then finally, the pull request that you raised for your feature branch counterpart in Azure DevOps in the cloud needs to merge with the main branch. So let's go for the demo for all of this. This is basically starting from scratch with an empty repository and taking, the command line or the Visual Studio UI-based approach to cloning the repo. And in here, I'm showing a Visual Studio, which has a good integration with Git, ever improving with, over time. So in here, again, you see this empty repo is now available locally. I still do a fetch to ensure that the local repo is in sync with the cloud. And right now I'm creating a new feature branch. Again, all of this can be done using other tools, Git tools, or just a command line. At this point, I'm adding code to my feature branch. I already have code. So the code here is for fleet management modules that you're all familiar with. And I've kept the code for the modules inside of metadata repository. So you see 3 different modules, and then a bunch of other folders that are not really relevant for being checked into source control. So I called them out in Git ignore, so those will be ignored. And there is a solution folder with the solution you see, and 3 different projects for the 3 modules. At this point, I will go in, look at the application explorer to ensure everything shows up. So as you're familiar from Tech Talk 1 and 2, this is how you can separate out the reference metadata that you get from Microsoft, metadata you may be getting from ISVs, and your own custom code that you're actually working on. So look at the folder for your own custom metadata. This is the one which I will update with my local folder where all of these modules code is. So in this case, since it is all in UD Dev ALM 2/metadata, I'll update that, save my config. So the configuration now knows where to point, but I will update the AOT by doing a quick metadata refresh. And at this point, it's all just validating that everything shows up. I can open code, make changes to the code. In this case, I'm doing the initial check-in, so the code is ready to be checked in. I save my solution and look at the changes that I want to commit. Put in a commit message, and I have different choices here. I could commit only locally to my feature branch without affecting the remote branch, or I could be working so that every time I commit, I push it to the remote branch as well. I chose to do local commits, and you see that reflected 1/0. That's only local commits. And I'm now doing the second commit of the build pipeline. So it's very important to practice continuous integration and continuous delivery. And for that, we want to use YAML pipelines because configuration should be treated as code. Anything that affects production, be it code or config or scripts, authentication policies, etc., they are best put in version control. And a good way to do version control for pipelines is to use YAML pipelines rather than the conventional classic pipelines. So you saw a bunch of the tasks. I'm not going over each of them. They are very well explained in our documentation. And Sourabh will be covering more details as well. You see the NuGet config and the packages config. So these are the NuGet packages that we'll be using for in our build pipelines. And you are familiar with these from existing build pipelines. This is the list of local commits I have in my feature branch. As you see, this is a full history going back to the changes that were done in the main branch as well. And I'm ready to push my changes. So you saw me initiating push, So these objects, 1605, they are all being sent remote. And it's pretty fast, depending on, how many objects are included in your change. At this point now, because my changes are already in the remote branch, I want to raise a pull request, which is a way to say that I want to move changes from my feature branch, remote feature branch, into our official branch, which in this case is main, is named main. And so I could have done that in Visual Studio as you saw, or I could do it in the browser in Azure DevOps directly. And with the title, description, and a set of reviewers, I'm ready to create a pull request. As you see, I've created it as a draft. You can then publish it, or you could have directly created it, published. At this point, when you publish it, the merge build kicks in. And this is the build that will ensure that the code that is being checked in is actually good enough. Right? It compiles. You can have unit tests included in this for different aspects of things. Though for X++ unit tests, we'll cover that later. We need to deploy to our UD environment as well. So again, I'm looking at the changes that I made, which I'm just showing you the experience that I have in ADO itself and the history of commits for that branch. And at this point, we are, ready to go, but let's look at the repository policies and the branch policies that help us ensure that it's more than, human validation that's happening, and also that sufficient controls are in place to, get the best out of version control systems. So in here for the main branch, I want to ensure that things get checked in only if they are reviewed by a minimum set of reviewers. I would have made the work items required. So every time there should be a work item linked to the change. That goes into more detail about the nature of the change. But definitely we want build validation to be in place. So in here, we have an automatic build being triggered every time there is a PR. Policy is required. And the build in question was the build that we had checked in. And the build here is complete. All required checks except for work item and PR review and sign off is done at this point. So we are basically going to add that work item link. You can see this is a demo work item we have for this. And this point, we will switch to the other experience by the reviewer. So, the changes were being done by me, and my coworker, in this case, Sourabh, is going to get this review request and going to have the same experience, but from a reviewer standpoint. So in Azure DevOps, in our programming model org and the repo Helix, if he goes and looks at PRs, he'll see there is a PR waiting for his approval. And looking into it, there is the overview, title, description, etc. that I had added, the work item I had linked, all the files that are part of this review, they show up. And all the updates that went into creating this PR show up also, all the individual commits. And so he can, take a call. And in this case, I think he will approve. And he can also set autocomplete, or I could have set autocomplete, or just complete at this point. So that is pretty much, the basic flow. You can learn a whole lot about more in our documentation, Microsoft Learn, and even go for trainings. And the thing to note is from a FNO and Dataverse and Power Platform perspective, we try not to constrain you, but try to enable you so that you can get the most out of all that Git and Azure DevOps has to offer. So over to Sourabh. He'll take forward the CICD pipelines.
Thank you, Pankaj, for setting up our baseline. Now that we have our baseline set, we'll decide, and once we know that all of our required PRs are already checked in, we'll decide to cut a release and deploy our code into the environment. To do this, what we'll be going through is a set of steps, which you can see here. The first two steps involves setting up the prerequisites that we need to basically create our build and release pipelines. And the third step and the fourth step are basically using those pipelines to build and then in a separate pipeline to deploy, to have that separation of concerns. So what I'm doing here is basically setting up two extensions, which Priyanka talked about before. And basically these two extensions are nothing but a set of tasks that become available to us in our organization when we install them. This can be installed using our marketplace, which contains a varied list of tasks, and we'll be choosing these two specific extensions. One is for Power Platform to be able to deploy it, and the other is the Dynamics that you're familiar with. Here, we are going into our organization settings, and this is the checked out. This is the organization that we have in and the Helix project that we are working on, and we can just go into the browse marketplace to find the exact extension that we want to install. So I'll be just going a little faster here, where basically once we go and search for the extension, we should pay special attention to the publisher and make sure that it is the right publisher, the Microsoft publisher that we're seeing. We can now see that both of the extensions are installed. The next item basically is the pack CLI that we have been talking about in our previous sessions. There are multiple ways to use this. We'll be using the VS Code way of installing it. So at this point, I'm just installing it on my developer box so that we can. This step is basically required to get a connection to the Power Platform environment that we have. And basically, all the tasks in the pipeline will be using this service connection that we are about to generate to talk to the environment. So you can see the extension is the pack CLI is installed, and it shows up all the commands that you can use with it. Once that is installed, what I'll do is basically create a connection, and for that I need to auth myself in. So I need to log in, and this is the environment which I am part of and I'll be using. So you can see the environment URL, the FNO URL, all of those. So I'll be just displaying all of those here. And this is the environment that I want to connect to. So I'll be using pack auth create command to get a connection. I would be doing that off screen, so for security purposes. And once we know that these are all this is the environment and we are ready, I'll be just authenticating myself. And once I authenticate myself, I'll see that I am already connected. Once this connection is complete, the next step in this connection is to create a service principal and client secret using the command that you're seeing right now. So this basically will create an application and register an application and basically create a service principal, which gives you a client secret that you can use to create a service connection, which the task can use to communicate with the environment. So yeah, this is the step to create that connection. I am giving it a name test demo 1. That will be the name of the application that we are creating. And as you can see, the environment is the link. Environment is the link to our environment URL. So yeah, this, as you can see, will create that application. It will also spit out a few other fields like the client secret, but we are again hiding that so that it is not directly visible. Once that is done, once the application is registered, the same application will be assigned a role in our environment so that it can communicate and act as an administrator on that. So this is the command that does that. So this is basically acting, the application acts as a user on that environment. So we'll see that this is now connected and assign the user the same ID as the application is being used on that environment. At this point, we are showing, when we go into the Azure portal, you'll see that a new application is registered. So you see the test demo 1. You can go into the app registrations and manage this. And you can also go into the enterprise applications to basically get all of the permissions and the users that you want to assign basically set up. So you can add users here. You can grant admin consent for all the operations that you'll be performing. And at this point, you have all of your prerequisites ready to go. And I'll be showing my authorization access that is being used to make sure that we go through all of this without a hitch. And you can see all of these are good permissions to be able to complete all of these operations. At this point, we'll return back to our project, and in the settings section, we'll be going over and creating a new service connection of type Power Platform. This Power Platform is again part of the extension that we installed. So once you install that, you'll be able to see this new connection type. And basically, you can create a new connection with all the details that you will be getting out of the commands that you run from PackCLI. We'll not display all of those informations, and you'll be able to see it. We can grant it permissions to the pipelines. And I have a sample here, which basically shows all of that. Yep. So at this point, yeah, we have all of our prerequisites set. Now, the next two steps would be building the actual build pipeline and building the release pipeline and using both of them. So let me just switch over. Yep. So in this case, we'll be continuing off exactly where we left in the previous video, and using the same application ID, we'll be creating the new service connection. Again, I don't want to directly show everything, so I just created it with the same application ID that you can see, and we'll be using this service connection from now on. At this point, there are two things that we're going to do. First is show the build pipeline in the YAML mode, and that is the recommended way. You can build the release pipelines also in YAML mode, but we'll be showcasing one of both. So the build will be in YAML and release will be the familiar classic UI that you see. At this point, this build YAML is taking in parameters, and you can make sure that you edit your YAML so that you can get as many parameters here as you need. And what I'll be doing is I'll be kicking off this build, and in the meantime talk about it, and by the time we come back, it should be completed. So I'll be using the previous runs to have the right parameters set, and I've kicked off this build. Now this is the YAML pipeline that Pankaj showed you in his last video, and what I have done is created exact copy of it using the classic so that you can completely understand this. And we'll see how we can map this to the YAML that you see before. So you must be familiar with the existing Dynamics 365 pipeline, and we are piggybacking off of that with some modifications. So this is the initial NuGet install, which basically points to the config and NuGet packages, NuGet config and package config, which you have in your repository. And this is used to install the 4 packages that you have in your artifact feed. This is a variable section, which is very useful for all the tasks and basically allows you to have all of your data in one place and use these variables throughout the pipeline without having to make changes in the individual tasks. This is the NuGet and packages config files, which contains the artifact and the feed ID. Which you can use to download your NuGet packages and install them on your agent. Once that is done, we'll just go into the same build solution task that will build all of your data. And this has not changed and remains exactly the same. The copy log files is basically used for copying over all of the logs that are generated as part of artifacts staging. Now, these two next tasks that you see are disabled by default, and I did that specifically because this is not actually required for the build process itself, but to be able to execute unit tests on the pipeline, which we'll talk about later. And these two will be basically publishing some things which can be used by the release pipeline. This is not the only way to do this, and I'll talk about that as well. But this is a good way to get everything that you need in the release pipeline itself to complete. So yeah, we'll revisit these two. But you can set them to be enabled or disabled that you want or not. And this again points to how you can use it by using the NuGet package and the variables, other variables which are using, so that you can configure it. At this point, we'll come back to the create deployable package. We have built our solution already. At this point, we'll be using the create deployable package, and we always want to ensure that we are on the latest version of the task. And this basically has changed from before, where initially you could only create LCS package. Now you can create both. With the option, you can choose the checkbox of the type of package that you want to create. This version, again, these two are something that you can pull out into variables, and so that you don't have to repeat, and are good candidates for the variable section. The output of each type of package is different. As you can see, if you are creating LCS package, this is the output. So you can basically create both the, as you can see, both the packages simultaneously. And you can see we always want to be on the latest version, and we are using the build output from the previous step as binaries directory. These are some of the, so if you see build artifact staging directory, build binaries directory, these are some of the predefined variables that are common across all Azure pipelines. And there is a predefined variable section documentation that you can go through to understand what each of them mean. The search pattern, again, is basically selecting everything in the build that we want to be deployed as part of the package. So once we do all of that and go through all of the variables and basically set this up, the last part is basically after you create this package, you will be publishing the packages as part of your artifacts list that we are going to use. So there is another task for that, the publish artifact drop. This is the same as the first two. We are just publishing different things to the artifact list that we see. I think this is basically exactly converted over. As you can see, it contains all the same steps, and you'll have very granular control if you use YAML. So we recommend that YAML should have precedence because it gives you other features like having control on the source and basically having a complete tracking management system to make sure that there is a track for all the changes that are going in. So, and the way you can do this quickly is that once you have everything installed in a task, once you fill out all the fields, you'll see that view YAML button will become enabled, and you can directly see what will be the YAML. And you can copy paste this part directly into your YAML file so that you don't have to create it from scratch. This is a good starting point, which you can further edit. So that's how you can create your YAML pipelines. At this point, we'll return back to our original build pipeline that we have and see the execution go over. So yeah, we are still running this. I don't think we should wait completely for this to complete. And yeah, now that we see that this has got completed with the same run, and the main objective of this was to create the deployable package, which we see that 3 things were published in our pipeline. The main thing we are going to focus on is the drop package. This is the cloud deployable package that was generated. It contains all of our modules that we wanted to deploy, and now we can use this to directly deploy. Please note the run number which we want to use. At this point, we are completed with our build pipeline. Now we have our release pipeline. This will only deploy the package, and we'll go over it by editing it The main thing to note here is the initial artifacts that the release pipeline should take in as input and download before doing any subsequent actions. This build pipeline is going to choose where the source it should come from, and please note the name of the source alias. So this is the folder where all those artifacts will be downloaded and should be used in our release steps. We'll be specifying which version of the pipeline to be used at when we actually run the deploy package, and that's how you can set it up. Now, coming to the actual release pipeline tasks, now you'll see that these are all different from the normal LCS deployments that you do, and this one is basically deploying to the Power Platform environment with the new package that we created. The installer task is basically used for making sure that all the other tasks are available on the agent, so this should be always there. The Who Am I task is a good way to identify and authenticate yourself, so it uses the connection string that we had earlier created and makes sure that we connect to it. The CRM URL, again, is part of the variables that you saw earlier and can be reused again throughout the tasks of this pipeline. This points to the organization. The next task is the main crux of the matter where we are doing the actual deployment. You can see you'll be using the same authentication mechanism of the service connection that we generated, and I'll be updating it to point to the latest one that we had generated just a few moments ago. Yep, that's the update. And the package file that you want to deploy is the one that we are creating. So you will notice the same name, build pipeline _ build pipeline, which you are pulling from the build output in the previous stage and the path to the entire DLL. So once we set all of this up, we'll be ready to be able to deploy. Since I made changes, I'll be saving this and making a commit to make sure that everyone understands what I did in this run. Again, this, if we are doing through YAML, we'll have much better control over the content of any changes that is being made so that we can keep track of what is happening. At this point, I'll choose which stage to select as manual or not, which version of the build pipeline I want to use, which is the same as the latest build we have, and create that release. Now you can see that this is going on, and we can go over the logs. And before we jump into directly checking out what is the output of this, this is the my connection. I think this is still going on. So in the meantime, I can show you one other important aspect to this release pipeline. That is the pre-deployment condition. We want to make sure we have multiple stages for different deployments, and we ensure that we have definitely set up some pre-deployment approvals so that we can get sign-offs as a best practice that Ankur had mentioned before, so that we can keep control on what is being deployed. At this point, we are just waiting for the deployment to complete. You can see that we are uploading all of our modules to the environment and do the deployment. And this has completed. And as you can see, the deployment is successful. Now, at this point we have created our build pipeline and we have deployed. The next step, or basically a new introduction, is basically be able to run the unit tests in the pipeline. This is a net new feature which is recently built, and basically this points to our code where we have our tests in the class. So you can see we have implemented this, and we want to build and deploy and execute this. We have to make sure that whatever is in our source code is initially deployed. This is the release pipeline we are going to use to make sure that everything is in sync. So we have to make sure that it is deployed before it is actually run, just to make sure that all the changes are in sync. Again, we'll be using the same initial stage with the same output. We'll be doing this. There are multiple ways you can run these tests, either in a build pipeline or in a release pipeline. For release pipeline, you have to have some more extra features that we talked about earlier to make sure that everything is available for the unit test task. For build pipeline, we'll go over that as well. So this one is, let's go into the actual tasks. So the first 3 tasks that you see, that were already there in the normal deployment package. We have additional 3 set of tasks that we'll be talking about. So this set connection variable task is basically used for setting up the output strings, which can be used in all of the subsequent tasks to be able to connect to the environment. It uses the same authentication mechanism that we had before, with all the output same. The only difference is in the output variables, where we'll be setting up a reference name which generates all of these extra variables that can be used in the subsequent tasks that we are seeing. This can also be done in YAML with the same. The NuGet installation part is required because the release agent is running on a different agent, so we need to have the compiler and platform package that we had installed in the normal build process. So we'll be reintroducing that. And the way we are fetching it is from the artifacts output directory, which we had published as extra steps to get those 2 files and install all the required components on this agent as well. So yeah, this is the NuGet stop that we had published earlier. We had looked at this one with main focus. Now the other 2 is basically the NuGet's package config and the 3 built modules which we had published as well to be able to discover all the tests that are present in that DL. We'll publish it to the output directory and you'll use the same path we'll use in the latest version again. And this is the same data was connection string that we saw in the set variables connection task. Again, we can pull both of the versions out into variables, and the output for the platform and compiler package is the one which we installed in the NuGet step. We'll be specifying the output location where all the build binaries are present, and we'll be specifying which module that we want to test out, which contains the tests. I just recently deployed everything, so I can disable this. But again, if we have YAML pipelines, we can be able to make sure that we are always able to track what the changes. So just so that the video becomes a little shorter, we'll be able to deploy this. We'll be choosing the same build output that we want, and we can see that the release is created. Now, if I go into the logs, I'll be waiting for it to complete. And this got completed. So if I go into the details, it first downloads all the artifacts that we want from the build output that we had specified, so that everything is available on the agent. And then we'll be going into the set variable connection task, which makes it available for the next task to have that variable pre-populated. And as you can see, it was able to find 2 test cases and basically waits for the execution to complete on the environment, submits that request, waits for it to complete. Now, this task is designed to fail even if one of the test cases fails, so that we know there are some cases which are failing. This is the way we can do it from a release pipeline. Similarly, there is no fixed way of doing this, so we can do this in a build pipeline as well. It removes the requirement of a few steps like reinstalling the NuGet packages, publishing the build output, and bringing it back again as part of the release. So this is a way we can do it in the build pipeline itself, because we do all of that before the checkout happens. The NuGet install happens beforehand. We have build solution step in that same run. So we can add the same unit test task in that field. It's just that we have to make sure that we have the deployed package beforehand on the environment to make sure that all the code is in sync. This again, I want to showcase only for demonstration. We don't want to use the build pipeline for actual deployment. And I'm just showcasing this to show the power of YAML pipelines too, so that you can see that you can set whatever parameters that you want for a particular input in here, and you can basically have logic that you can turn on and off that is required, if you want to use client secret or not, if you want to execute tests in this run or not, all of that. So these are just recommendations, and you can basically be creative and innovative with what you want to control and according to your organization's needs. At this point, I think Pankaj can take over to talk about one other feature that we'll be going through in the pipelines.
So what we'll do now is to round it up with a kind of special case around ISV licensing. So the pipelines that we've seen so far, you should be flexibly able to use Classic or YAML, though we prefer YAML. You should be able to divide them up between just validating the build versus build plus deployment to a given remote environment, plus even executing unit tests. As we said, go and use Azure DevOps to its fullest. We don't try to constrain you on that at all. So in this case, we have an existing pipeline, but we added a task to add ISV license to a new package. So you saw in the previous demos that we had added fleet management modules. In this one, we are beginning from backwards from a successful build and showing that this build was related to a particular change. That build then, reduced these artifacts. We open up one of these artifacts. So there's a new module we added apart from the 3 fleet management. This is the Unified Experience module. Basically has a demo form, a table, menu items, etc. But the most important thing here is that it has configuration hiding or enabling or disabling certain features in the form based on the license being present in the target environment. So looking into this change itself, the PR behind this. So we made a change. In here you see the particular parameter we added. This parameter is useful in helping you keep things organized. We sort of talked about variables earlier. Now we are talking about one other layer, which is parameters. So this ensures that each run of the pipeline can be different from the other. So the default parameters ensure, just like with regular coding, that you don't have to actually specify the values, and the default will be taken, but adds that flexibility. Moving on, the main task here is this license add, XPP add license to package task, and the important inputs are package type, which is UDE unified package type 1, the model name to which we were adding that, and everything else we can use from the parameter that is specified. The thing here in terms of code is this configuration key. So this is going to hide certain aspects in the form, and that's pretty standard how you do configuration management and licensing. A few other things of interest are the ISV cert that was added, the XML file, but all of this is also standard. So we move on to important aspect around Git, which is Git ignore. So we talked about it earlier. In this case, we also made a few more changes. Like when I built locally, there were these log files produced, and I wanted to ignore them from subsequent builds. Another thing to note was that you can have builds that only produce the artifact and do not deploy, and in subsequent pipeline runs, you don't have to build the same thing again. You can just deploy from an existing artifact. Just to round things out, the license file path. In here, you see the path is, I use a wildcard. You could specify fully, where you wanted the license file to be picked up. And this task also you could repeat as many times as you wanted for each of the different modules that were being licensed. And this corresponds, as you see, to the actual file in here. So let's move on to one other thing, which is the logs that you see for builds, which you can find in Azure DevOps, can be supplemented with the logs in the environment. So you're deploying to a given environment, and note that it is your environment. You have full access to what's behind in the environment. And one of the things important to you is the operation history. This is how you can get to it. And within the operation history, you see all the changes done by you, done by other co-workers who are working in the same environment. And you can even download these logs for unit testing. If you're doing it from Visual Studio, you'll see those logs reflected in Test Explorer directly, but you have access to it. So that's most of it, what we have time for. And we will now move on to a few things around resources, which Priyanka will cover.
Thanks, Pankaj and Sourabh, for those insightful demonstrations. Those were really detailed and really good. So as part of resources, we have this FAQs. We have listed down some of the key FAQs. You can have a look later. And if you have additional questions, please keep posting in Q&A panel. We will talk about those, or we will be reaching out later. And here in this and next slide, we have listed down all the required resources. Please go through if needed. In this slide, we are more talking about Git-related links. Just go through if you want to know more on the Git. As we wrap up our session, the main key takeaway is the importance of fully understanding the Unified Dev ALM from start to finish and embracing Git for version control. We also touched on the branching strategy, emphasizing that it should be tailored to meet the project need and facilitate various development and testing environments. Furthermore, we explored the development and release flow, including setting up Git repositories, development process, reviews, build policies, testing, etc. Additionally, we showcased CICD processes, highlighting their significance, including the classic and YAML pipelines for build, release, and testing. Now, let's go through the questions what we have got from audience. Taka, can you please share if there are questions unanswered and we need to highlight those?
Okay, yep. The first question and answer is the method of setting up the metadata config shown in the demo the recommended way of doing this versus using symlinks as I have previously seen blogs on?
So symlinks are not really required at all. It is just a layer of flexibility that you could have. Feel free to use either. The one that I showed just works.
Thank you. And one more question. So, do the YAML release pipeline report status to the DevOps items?
Yeah. So this is not really tied to FNO or Dataverse or Power Platform. It is completely Azure DevOps feature set. So I think it could. It just is a question of settings. But yeah, the authority on this would be, on Microsoft Learn and so on, accessible.
Okay, thank you. So it's about time. Thanks to our presenters and to you, our audience, for attending us Tech Talk today. We hope you have a great rest of the day ahead.